So in this case, we are going to simply consider the basics of our triangle rules as we are having these as applications. Remember, we managed to work with all the basics that we have on a triangle, but sometimes you'll be given questions where you need to prove or to show that you have got maybe a given diagram. And from that, there's a statement that you must prove or that you must show in terms of the given symbols or in terms of the given letters that are on the diagram. Just like what you are given, show that this is can be written in this manner. This one can be written in that manner. So the question is, how can we show that? How can we prove such statements? It is an application of the solving of triangles that we had. This one. It is an application, meaning to say, as part of the trigonometry, we also have applications that should be used of the trigonometry, as well as the understanding of the triangle. So I want you as an individual basically to revise because of these proofs that we are going to consider. We are going back to what we did before as part of our trigonometry. Remember, use of identities, basic ratios that we have under trigonometry. All right. So these are some of the useful identities that you must remember. All right. So you must remember these identities. Remember, we have got the reduction angles, all right, from our reduction formula or the reduction angles, where we are given uh, certain angles that are bigger than an acute angle, and we want to rewrite them in form of an acute angle depending with the quadrant where each of these angles do lie. Remember, those are the basics of your reduction angle. Using the cast concept, we know that in the first quadrant, we're going to have theta. Second quadrant, 180 degrees minus theta. Third quadrant, 180 degrees plus theta, and the fourth quadrant, 360 degrees minus what? Minus theta. I referred to all these basics and remember the cast concept. So here, guys, we talked about this. Just revisit your notes. You are going to need some of these in your revisions. Remember to reduce each given angle from the third quadrant, from the second quadrant, third quadrant, fourth quadrant. They can be written in form of what? In form of theta. So sometimes as we to consider this in the application of the solving of triangles, basically we need to understand the relationship, especially here on 180 degrees minus theta, in case that you have got that consideration. 180 plus theta, 360 minus those ones. Do not worry about those. Do not worry about that extension, because you're dealing with a triangle. Remember, 180 degrees, sum of what? Interior angles. So if it is more than that, cannot consider. So just basically the relationship. So I'm not going to go into much detail since we had this one as a separate topic, but I just want you to remember everything that we talked about, and also some of the basic identities. Remember, if we refer to the tan, of theta. We say this is the same as the sine of theta over the cos of theta. It is another part that you must put into consideration, and it's reciprocal. If we've got 1 over tan, it means this can also be written as a reciprocal. Remember, 1 over A over B is the same as interchanging this as what? B over A. So whenever we are going to refer to the reciprocal of a tan, which is 1 over the tan of theta, what is going to happen is that we just have 1 over this. So it is going to interchange and have what? Cos theta over sine theta. Just like this concept, B over A from this. So somehow we have got a consideration where we need this, use that part. Maybe you have got your Pythagorean identities. Remember the sine squared of theta plus the cos squared of theta, which is going to give us a 1. And from this, we can play around, make the sine squared the subject of the formula. We do understand that if we make this sine squared the subject, it is going to be given as, take the cos squared to the other side, 1 minus cos squared. We can make the cos squared the subject of the formula, meaning to say cos squared of theta is going to be what? We take the sine to the other side, 1 minus sine squared. Know your basics. Your core functions, remember the core functions as well. Your core ratios. We referred to these whenever we are given the sine of 90 degrees minus theta, we know it is equivalent to cos. It changes sine to cos. The cos of 90 degrees minus theta will change to a sine. So basically, you'll be working sine, cos, sine, and cos. Yes, it can be a condition where it is more than 90 degrees. We can have the sine of 90 degrees plus what? Plus theta. I also talked about this co-function. When it is sine of 90 degrees plus theta, this will give us the cos. But when it is a cos of 90 degrees plus theta, it will give us what? A negative sign. Right. So basically, guys, we talked about this, and also the double angle can be used. All right, somehow, the double angle. Remember, on the double angle, we have got the sine of 2 theta, which can be written as 2 sine of theta cos theta. 2 sine theta cos of theta. Okay. So basically, guys, those are the basic identities. We shall add some of, it's not like we did not mention these identities before. So where we've got something that is missing, we'll see as we shall be attempting our questions. But those are the basics that you just need. So on the triangle, you go back to the basics of your 2D, remember, in your grade 10, every part that has to do with trigonometrical ratios. All right, remember your trig ratios, the SOHCAHTOA concept. All right, the SOHCAHTOA concept. Remember your Pythagoras. All those, they can be used. You remember your Pythagoras. Remember also the use of the rules, the sine rule and cosine rule. Remember, we talked about those, and even the area rule. They can bring something that has got area inside. Then what are you going to do? Apply that. Those are the basics that you have on the rules of a triangle, from the trigonometrical ratios used on a right-angled triangle. Pythagoras, the sine rule and cosine rule, which are used on a non right-angled triangle. So the proof, it is just like, can you show us how to actually approach to this answer? You are given the answer already. What you need to do is to show the steps how to obtain the given answer. So there's a difference between when you are given a question, you are solving for the triangle. No one told you to prove anything. You can solve in the way that you want, as long there's something that is mathematically proven. But a proof now, you must consider also the mind of the examiner to say, okay, according to the question that I'm given, what can I do to have this? All right. So let's consider these two questions. Use the given information in the diagrams to show that 1.1, we have got this diagram. And from that diagram, D is equal to K sine of beta over sine alpha plus beta times what? The tan of theta. So this is what we are given to show or to prove. Okay, so let's take our diagram. Let's just hope it's going to be clear. Let's just try and have it this way. All right. So if we are to consider our diagram here, the D that we need is this one. This is the D that we are given here. So the question is, how can we obtain the D that we are given there? It is from a non-right-angled triangle. Considering there are two triangles here, we have a right-angled triangle, and we have got a non-right-angled triangle BCD. This is where we are given our D. But let's consider to say, if we were to find this D, how are we going to find the D, this one? Okay, let's consider what we have. In this triangle, BCD, it is limited. We have the side D that we are supposed to find here with a corresponding angle. All right. There is this angle, which is alpha here. Does not have a corresponding side. We are not given this letter of the side to say, or the symbol for that side to say it is represented by the letter M or the letter K. There is nothing there. All right. The angle D is not given, but we can determine this angle D. So let's say we have angle D, but we do not have the corresponding side there, so that we can even use the sine rule. We are limited. So meaning to say we are now forced to focus on this triangle ABC before we look into the second triangle. All right. So on 1.1, I want you to see what is happening here. BCD, in triangle BCD, in triangle BCD, it was limiting us, this triangle. This is our triangle, B to C to D, like this. That's our B, our C, and our D. It was limiting this triangle because we have got the alpha and we have got the angle beta here. We have got the D. That is what we are given. So if we are going to use the sine rule, it must be side to an angle, side to an angle, or it is this side to this angle. But it is limited. Why are we even talking about the sine rule? Guys, look at the answers. There's nothing about a cos there. There's nothing about a cos, so it's not going to be anything about a cos. Even if you're to use the cosine rule, remember the cosine rule to be used, we must have an included angle to determine that side. So if it was a condition where we are to use the cosine, even the presentation of this D, this one, we know that for a cosine, remember A squared is equal to B squared plus C squared minus 2BC, the cos of what? The cos of A. This formula alone, the presentation and what we are given here does not even tally at all. Does not even tally at all. So it is a sign in your mathematics to say, okay, no, this one is cosine is actually out. There's no, those guys, you are given this question, there is no one who is telling you to say, follow these steps. It's in your mind. So some of the things you can put them away. Say, okay, this one, because it's not part of the question. All right. So we are left with a sine rule. But the sine rule must be side to an angle, like I was saying before. So we are basically we're going to need the angle that correspond with the side. Right? Which is now considered from the triangle ABC. There is a side which is being shared that is common here, side BC. So we must think of finding that. BC corresponding to angle D. So we must find side BC first. From where? From triangle ABC. Because it corresponds with angle D. But the question is, where is angle D? Because we cannot see it. We can't see it. All right, guys, how many angles are we given? 2 angles. So we can find the third angle by simply subtracting from 180 degrees. So it follows that the angle that is at D here is going to be 180 degrees minus what? The sum of these 2 angles, which is angle alpha and what? And beta. That's alpha plus what? Plus beta. That's the angle that is at D. So at D, we have an angle there. But what is it that we do not have? It is the side, BC. So let's say we have got a side which is BC. We're going to find D this. Guys, you ignore as if you take this one because you want to prove D. So you take D as if it was not there. So you're going to use the sine rule. D over sine of this is equal to BC over sine of this D. But we do not have BC. That's where we are limited now. We go back to the triangle ABC. You see, how do you share this information? So we are limited first to find BC. From where? Triangle ABC. All right? Which is a right angled triangle, this one. So it is easier for us to determine the length of BC. As we are given the angle, which is theta here. According to the angle theta, AC is what? The opposite. Remember, a right angle triangle. And BC is what? The adjacent. So we are back now to the trigonometrical ratios application of the SOHCAHTOA, as I was saying here, the trigonometrical ratios again. So which ratio are we going to use? Opposite and adjacent at the same time. That's the tan from SOHCAHTOA. Opposite, adjacent on the tan. So it follows that the tan of the angle, which is theta, is equal to what? The opposite. That's AC over what? Over BC. All right. Where in this case, tan of theta is equal to our AC. That's K. This, we are now indicating the symbol which is given there in place of the number that was supposed to be, as we are given what? A symbol there, which is symbol K over what? BC. Remember, we want to find what? We want to find BC. So it is going to be over BC. So let us find BC. So the question is, someone will be asking, how can we find BC? Well, at least we do not have theta and K. We are to find BC in terms of the given symbols or the letters that we are given, in terms of K and in terms of theta. All right. So that was the concept. You can cross multiply BC times the tan of theta. So it is just like make BC the subject of the formula, all right? 1 times k, that's a k, so you can divide by the tan of theta, by the tan of what? Of theta, like that. Like that, we've got our BC. So this is the length of BC in terms of k and what? And theta. The symbols that we are given, k and theta. So BC, we could have actually in a normal way from our previous classes, we were supposed to have this BC as a certain number numerically. But in this case, it is what? Symbols that we have. So don't be stopped by that. With the symbols that are given, also cross-check with the question. Am I in the right direction? Do I even see these on the question? You can see, okay, there is something about a K here, and we can see something there. So it shows that you are in the right direction. Okay, let's leave this one. We have got the BC. Remember, we need this one for the triangle BCD. For the triangle BCD here, which is a non-right angled triangle. We do not have a 90 degree in this triangle. It's a non-right angled triangle. All right. But we have got the length of BC. So let's put it here in place of BC in this triangle. Right. So here I'm going to check this. That's K over what? The tan of theta. So that's our BC there. Remember, I was saying we were being limited to use the sine rule because of that side BC. Now that we've got our side BC, let's use our sine rule to prove the given statement here. All right. So how can we find D? That is the question now. From this triangle that we are given, find D. All right. So we must find D. In terms of those letters that we saw from our question, from triangle or in triangle BCD. So in triangle BCD, how can we find D? It is like D, it's not there. How are you going to find this side BD? In a non-right angle triangle where you have got an angle which corresponds to the unknown side. And there is an angle which corresponds to the known side. Sine rule can be used. Remember, A over the sine of A is equal to B over the sine of what? Of B. The side to be calculated, which is what? Which is the D. Remember, we're given that the D there. The side to be what? To be calculated. But we act as if it's not there. But that is the one that we need to calculate, which is what? Which is a D over what? The sine of the corresponding angle to that D. So D corresponds to which angle? Angle beta. So that is the sine of beta. So this must be equal to what? A complete ratio here. A complete given ratio with a side and a sine of the angle. So alpha is limited because we do not have the side there. So we use BC and what? The angle D. Side to the corresponding sine of that angle. So that's K over tan theta like this. All right. So this is over what? The corresponding sine of that angle, which is sine of, as we can see, the angle is 180 degrees minus alpha plus beta. All right. So that's our angle, this one. So do not worry with this presentation, guys. You cannot rewrite this angle anyway, the way that it is here. But where it is here with a sign, this sign that we see, it can be rewritten, reduced into a smaller, which is by the reduction concept. Remember, that's where our reduction formula plays a role. All right? So it can be reduced. Do not worry about that. All right? So that is what we are going to have. So in this case, guys, remember, we must find what D. So what is affecting our D in this case is the sign of beta. Guys, you solve the way that we're just solving when there were numbers here. What were you going to do? What were you going to do? If you're solving for D, you're going to remove the sign of what? The sign of beta. So, all right, so let's get rid of the sign of beta here. We multiply by the sign of beta over 1. So to the numerator, so this can cancel. We have got our D, which is equal to the product of this over this. All right. So on the product there, let's just try to rewrite in a way which can make sense here. This is just like A over B times a C, a fraction times a certain odd number like that. This is the concept. How are you going to multiply? You multiply A to C, just numerator, then B to 1 like that. So it was going to be AC over what? Over B. Mathematically from our algebra, this is your grade 9 mathematics. All right? So meaning to say, it was going to be K to the sign of what? Of beta. So that was going to be K sine of beta over what? The tan multiplies the 1. It's in the numerator, but it will be like sine beta over 1. So it's like tan of alpha times what? Times 1, which is the tan. Tan of what? Of theta. That's our theta there. Okay. Then the denominator here is on its own. Right? It is on its own. So we can have that part of the denominator as its own, on its own like that. But like I said, this can be reduced, this one. Okay, so let's go back to reduction. When dealing with a sign, 180 minus theta in the second quadrant, sign is what? A positive there. And we do understand the sign of 180 degrees minus theta, which is the angle that is our acute angle or the reference angle, is same as the sign of what? The sign of theta. 180 degrees minus theta. So in our case, this is our theta, all right? In our case, you treat this alpha plus beta, this one. This is the one that you treat as your theta. So it's sine of 180 degrees minus whatever that you're subtracting there, it is the same as this part, the theta. So if it is going to give us sine theta here from this reduction, if it is going to give us sine of the angle that is our reference angle there, therefore in this case, it is sine of what? This what part that is under the bracket, this one, inside the bracket. Alpha plus beta. So that was going to be sine of alpha plus what? Plus beta. This is where we are. If we are to check, guys, we have done the exact thing that was supposed to be applied mathematically. But if we look into the answer that we are given, it is not the same. If we go to this answer, the presentation is not the same. All these we have on our solution, but presented differently. So are we going to leave our answer like this? No. We must rewrite the way it is written there. So what is the concept? How can we simplify? Where there is a fraction to another fraction. Remember, I say this concept, guys. A over B over C like this is the same as A over what? You multiply the denominators together. The denominator of this fraction to the denominator of this fraction, which is what? C. So it will be A over BC. A over BC. the numerator as it was, the numerator as it was, the numerator here, which is what? K sine of beta. K sine, or as it was, over what? The BC, that is the denominators, the tan of theta and the sine. So it is the tan. You can rewrite the way that you want. You can start here, you can start with a C times B. You can start whatever that you want. So you can even start with the sine of alpha plus beta times what? The tan, it is there, which is the tan of what? Theta in the denominator. So you were already having the answer there. You're already having the answer, but presented in which manner? Be very careful. So there we go back to our algebra concept. All right. So this is how we prove, guys. As you can see, that is what we have been asked to show exactly from the question. So you must consider the steps. It's not that much. Steps. From what I'm given, you see it's not complete. Then focus with another triangle. What can I have from that triangle, which is part of the triangle that I'm solving? There was no need for this in triangle ABC for us to focus with the AB. There is nothing there in AB. That has to do with triangle BCD. There was no need for us to even finding this side. It has nothing to do with this. But the BC as a common side can help us. So that's how we play around. All right, let's look into 1.2. Try to figure out again. That's a proof. So in this case, I'm just going to be quick to the question and see. We are being asked here on 1.2 to show that this can be written in that manner. Okay, let's figure out. D is the one that we want. We need this D here, which is exactly just like the same what we had in the previous question in triangle BCD, which is a limited triangle because we just have an angle which corresponds to the side, but this angle does not. There's nothing there. So it means there was something about BC to be calculated first. Here, BC. BC first. From where this triangle, which has nothing to do with the D that we want. You see how the two triangles share the concept. All right. So let us first find BC from triangle ABC. Okay. So this one is just like previous question. Triangle ABC is an isosceles triangle. The reason being side K and K, same symbols. Same symbol that we are given. It simply means it's just like we're given 5 and this is 5. This is 6, this is 6. So to represent the same side, to say these two sides are equal, they will use the same symbol there. If they are different, they can use K and use another letter to which is M to show that they are different sides. But using the same symbol like this, it shows that the two sides are equal. That's an isosceles triangle. So given the angle of theta at B here, it simply means we also have the C, that is, remember, angles that are opposite equal sides. So that's at C. Our angle is going to be what? Exactly the same as the angle that is at what? At B. So angle C is equal to angle B, which is angle theta. Remember, these are angles opposite equal sides. All right, remember this, guys. Okay, no problem. So as we are focusing with triangle ABC, how can we determine the length of BC? Okay, if we are to notice here, it's a non-right angle triangle. And these two angles cannot help us because this one is to this one is to this. So there is nothing that is going to help us. So let's find the third angle, which is at A, the third angle. Remember, we have got two angles. So angles in a triangle, 180 degrees plus what? Theta plus theta. And theta plus theta is what? 2 theta. This is what we have. Or we can consider this one this way. We can consider that one as 180 degrees minus 2 theta. Okay? Then you can use your cosine rule, which is fine. Another way that you can use, this one was going to work in a proper way. Let me show you another way which can maybe most of you guys can easily relate to. Let's say you take the angle that is at A like this, all right? Remember the properties of an isosceles triangle. If we are to draw a line from A to the base of the triangle, that line is actually the symmetry. It's a line of symmetry, this one, which divides our shape into two equal parts. It does not only divide the shape into two equal parts, but it is a perpendicular bisector of BC. Thus, BC is being divided into two equal parts at 90 degrees. So I can consider that. Okay, let's say we just have a point. Okay, let's just use any other letter which is not on our diagram. We've got A, B, C, D. All right, so let's say we just call this point E, which is at the perpendicular to the ground here. It follows that you can use one of these two triangles. You can use triangle BAE. You can use triangle AEC to find the side BE or to find the side EC. Because these two, they are exactly of the same length. From B to E, which is the adjusted point of our triangle there, it is the same as from E to C. You could have worked with the angle of A there, which is fine. So it follows that if BE and EC is the same, therefore we can find BC because BC is simply 2 times one of these. You can 2 times BE, or it can be 2 times EC because EC and BC, they are the same, any one of these. So it is up to you. Which one did you calculate? Did you calculate EC or you calculated what? You calculated BE. So the question is, how can we calculate any one of these? All right, let's say I want to calculate BE, this one from B to E. Guys, it's a right angle triangle. Look at this, guys. Do not worry about, say it's the complete triangle there. Look at this triangle properly. ABE. What do you see? Proper right angle triangle. With the angle of theta, you know the side that you're supposed to calculate is what? Is the adjacent. BE is the adjacent, and this is our hypotenuse. So which ratio are we going to use? That is called adjacent and hypotenuse at the same time from our SOHCAHTOA. Adjacent hypotenuse is on the cos. So that's the cos of angle theta is equal to the adjacent, which is BE. All right, remember I said you can use BE, you can use EC, depending on the triangle that you're given. So that's the adjacent BE over the hypotenuse, which is what? Which is K. So therefore, BE can be calculated. This is over 1. Just cross multiply. That's 1 times BE, which is BE is equal to K times the cos of what? The cos of theta. So we have got BE. But we say the whole of B to C there, the one that we erased, is the same as what? Product. 2 times what? 2 times B. You multiply whatever that you got by what? By 2. So therefore, BC is equal to 2 times what? BE, which is 2 times K cos of theta. So that was going to give us 2K cos of theta. That's our BC. All right, which is very, very important to the triangle that has got the letter D, which is the triangle that we left, triangle BCD, in triangle BCD here. So this is how it works. You had to calculate the BC first using any concept or any way from triangle BC. But as you look into the formula also, guys, just figure out. So now I have got this, all right? Let's take this BC, all right? BC, BC, BC. Let's take our BC here, 2K cos theta. So I'm just going to write it here from B to C. All right, so this one is 2K cos of what? Cos of theta. That's our BC. So now we can use the given triangle BCD to find D and show that this is what we are going to have. So find D now. From where? From triangle BCD, which is also a non-right angle triangle, guys. This one, a non. Remember the first one, it was a non-right angle triangle, and we had to make adjustment to end up with a right angle triangle. But in triangle BCD, it is completely something else. So let us apply our sine rule. Remember the concept where the angle corresponds to the side. The angle corresponds to the side. Sine rule can be used as we are to find the side D. That's A over the sine of A is equal to B over the sine of B. So the side to be calculated, which is D over what? Sine of the corresponding angle. So that's D over sine of what? Of alpha. This is equal to B over sine B. What is complete from what we have from the diagram? What is complete? So that's where we take the 2K this side, 2K cos of theta over what? The sine of the corresponding angle, which is the sine of what? Of beta. That's it. So let's play around with this question until we have the D that is given to prove, to show that here. Until we have got this. All right. So there it is, the presentation. It is K sine of 2 theta times what? Times alpha. All right. Let's see. Over sine theta times what? Sine beta. No problem. Let's see what we can do. We need D, remember? So let us just get rid of the sine of what? The sine of alpha. All right. So let me try and do this here. Okay, this one. We need this D. So let's get rid of what? The sine of what? The sine of alpha. The sine of alpha, both sides. All right. So, okay, sorry for that. So we're just gonna get rid of this one. Okay. So that was gonna cancel, and the D is now equal to, this is just same as over 1, guys. So just multiply the numerator to the what? To the numerator. So that was going to give us 2K cos of theta times the sine of alpha, like this. Everything over what? Sine theta, sine beta times 1, which is the sine of what? Which is the sine of beta, like this. Which is completely different from what we were given. As we can see, guys, this one is completely different from what we have from the answer. Let me try to do this. If we are to check our answer here, it is completely different. So the question is, what happened? They want you now to go back to your trigonometry. The trig part. The trig part. Okay? The trig part. You applied everything about your triangles. But what about the trig part, the trigonometry, identities, this and that? Which part that we are supposed to get rid of? Let's look the question here. Let's look into the question. There is sine only here. If we look properly, it's all about sine. Sine 2 theta, sine this. Sine theta, sine beta. There is no cos. Our answer has got a cos. So the question is, how can we remove the cos? And if you check, there's a double angle. I sine 2 here, guys, sine 2 theta. Basically, you're just supposed to work with that sine on its own. So you go back, remember, your double angle, the sine of 2 theta is equal to this one. So this is mathematics, guys. You play around with the formula to get what you need from the solution. The sine of 2 theta can be written like this. 2 sine theta, cos theta. These two mathematically, they are proven that they are the same. If A is equal to B, B is equal to A. So therefore, from the same concept, if these two, they are equal, let us get rid of the cos of theta from here. Here. There's the cos of theta there. Simply make cos theta the subject. So we divide by what? 2 sine theta, divide by what? 2 sine theta, like this, so that these can cancel. From the same identity, guys, is just like cos squared theta plus the sine squared of theta is equal to 1. Were you not writing cos squared theta is equal to 1 minus sine squared theta? You were writing it like this. It is not an identity, this one that was created. No. It's from here. It's from. You play around with one identity because it's already mathematically proven. So whatever that you do here is also mathematically proven. So dividing by 2 sine theta on this identity, which is our double angle for sine, is not wrong. It is a proper way because we are taking it from a proven identity. So therefore, we can say the cos of theta is equal to what? The sine of 2 theta over 2 sine theta. Mathematically, this statement is true. So let's go and replace it there in place of a cos. So therefore, D is equal to 2k times what? The cos of theta is the same as sine 2 theta over this. So you're going to write the sine 2 theta on top times the sine of alpha here. The denominators, there was sine of beta and what? This one here, this one, the 2 sine of theta that we left. Remember, we wrote sine 2 theta here on top. So the 2 sine theta will be written in the what? In the denominator. Just like that. Just like that. You see, they want to play around with you guys. If you are not into your identities, then you just, no, this question is wrong. This question is wrong. This question is wrong. No. Revise all of your identities and trigonometrical ratios. Then you see this is just a walkthrough type of a question. All right. Anyways, let us simplify further. So therefore, the value of D written in form of the symbols, as we can see here, it's a product and also a product. So these can cancel the 2 and the 2. There's nothing that is common left that we can cancel. So meaning to say we can rewrite our answer as it is k times the sine of 2 theta times the sine of alpha, everything over the sine of what? the sine of beta times the sine of theta as it was given on the question. So writing sine beta times on these two does not matter, guys. Remember, AB is same as B times A. It is one and the same thing. One and the same thing as it is written here. Do revise, guys. Do revise as many questions as you can. Mathematics is all about what? More questions. The more you practice your questions, the more you understand the concept on how to answer these questions. All right? So I want you to challenge yourself as an individual as you are preparing for the exams or the tests which are ahead of time to work out as many question papers. Just try to figure out how do they ask these questions. With the basics that I know, how can I attempt the given question? That is the mindset that you must have as you are preparing for the exams which are ahead of time. But that is it, guys. Till we meet again.